right, good morning. This is Professor Grenfell's Math 12 Statistics class. And today we are going to continue on with a lecture for Chapter 9, Section 2 on testing the difference between two means. And that is using the t-test. So this is when we do not know the population standard deviations. So example 9-5 on page 501. In this example, we're going to be building a confidence interval for the difference between two means. And in this example on page 501, it says to find the 95% confidence interval for the data in example 9-4. So write that down real quick. Example 9-4 was on work absences, so I'll read the details of this. It says a study was done to see if there is a difference between the number of sick days men take and the number of sick days women take. A random sample of 9 men found the mean of the number of sick days taken was 5.5. The standard deviation of this sample was 1.23. A random sample of 7 women found the mean was 4.3 days and had a standard deviation of 1.19 days. And then they go on to ask about that claim and instruct you to perform a hypothesis test to test that claim. In this one, we're going to be building a confidence interval, and notice the same value of alpha, because our confidence interval is 1 minus alpha. So 1 minus 0.05 gives us 0.95. Right? So let's go over the important formulas. So I'll start it with the margin of error. And this is going to be a critical t value, t subscript alpha over 2 times then our standard deviation for this distribution is going to be the sample standard deviation squared divided by sample size, and then plus those two things, the variance for the second sample and the second sample size. That's what we're going to be calculating. All right, let's go ahead and plug those values in. So the critical t value, we're using 6 degrees of freedom, because that is the minimum of n subscript 1 minus 1 and n subscript 2 minus 1. So our critical t value for 6 degrees of freedom and corresponding with a 95% confidence interval is the same as the critical t value in the last problem, because everything else is the same. It's just asking us about a confidence interval instead of a hypothesis test. So that is why we have 2.447 for our t subscript alpha over 2. For this part here, we're going to be substituting in 1.23 whole quantity squared, all divided by 9, because that is the data for the first population, or the first sample. That's the sick days standard deviation or the min. Here's 1.19 whole thing squared, because that's the standard deviation from the second sample, divided by 7, the second sample size. And so completing this calculation gives us a margin of error of 1.489. And then what we do on top of that is we'll say it like this. I'll say mu subscript 1 minus mu subscript 2. That's going to be equal to chi bar 1 minus chi bar 2. And then we'll say it like this, plus or minus the margin of error. Okay. Now remember, that's not technically proper, so this is actually going to be a double inequality. But here, I'll just write down what we had. So mu subscript 1 minus mu subscript 2. That's what we're trying to get our estimate for. This is going to be 5.5 minus 4.3. That is chi bar 1 minus chi bar 2. And then I'll say plus or minus 1.489. Okay, so this simplifies to 1.2 plus or minus 1.489. And if we do 1.2 plus 1.489, we'll get 2.689. If we do 1.2 minus 1.489, we'll get a negative 0.289. And so that is the range for the difference in these two population averages, these two population means. Right? And here, the thing to notice is that 0 is one of the values that is contained in this whole range. And so this means that since 0 is contained in this interval, that is one of the values that we would say, okay, yeah, that's close enough. That is what it is equal to. And since mu subscript 1 minus mu subscript 2 is close enough that we'll say that it's equal to 0, since it's equal to 0, that means there's no difference between these two populations. And that was the same result that we had come to in the last example, performing a hypothesis test in order to test that claim. And we'll conclude there. And that is, essentially, that is it for Chapter 9, Section 2. So we'll go into 9-3 on the specialty test next time.